Hello,
Hello,
my
my
wonderful
wonderful.
viewers. Welcome once again to Frequency Online Maths. Today, we are going to treat an important topic in mathematics called what? Indices. This is the basics of what? Maths. Indices is everything we do in what? Mathematics. So, I'm going to elaborate more on this word, indices. So, stay tuned. Now, when they ask you, what is indices? What will you say? I'm asking you the question. What will you say? Okay. So, indices simply means index, exponent, or what? Power. This is a mathematical expression that involves what? Base and what? Exponent. That is what? Indices. Anytime you hear what? Raised to the power. For example, let me bring this thing. Are you seeing my bass guitar? Now, let me show you something on indices on this bass guitar. This bass guitar now you are seeing here. This place is what? C. C. Are you seeing it now? C. Let me just run the solver. So this is the solver of what? C. Now, indices simply means exponent. If I raise this C now up, it is what? Indices. The exponent of what? This C, which is what? Key B. Are you seeing it now? C, I raise it up, is what? B. So the act of raising this thing up is called what? Indices. It is what? Index or what? Power. Exponent, index or what? Power. So that's it. Although bass is coming down like B flat B, C, C sharp, D, E flat E, F, F sharp, G, G sharp, A, and so on and so forth. So that is the what? Explanation of what? Indices. Let me keep it. So I'm back. Indices. I hope you understood it with this example I gave. Anything raised to the power. Like this marker now, if I put it this thing, it is what? Index. It is what? Something on top raised to the power. After indices, you get what? Tetrachon. Repeated what? Exponentiation. But that one is what? By the way. For example, if you have something like this is what? Two tetrachon 3 or two hyperpower what? 3. But that one, you shall still treat it. So indices, let me write it. Indices simply means exponent, index, or power. Full stop. It is a mathematical, I hope you can see it. It is a mathematical expression that deals with base and exponent. Do you understand it now? So indices simply means exponents, index, or what? Power. It is a mathematical expression that deals with what? Base and what? Exponents. Now, example. If I have something like 8, if I want to express this thing in index form, it will be what? 2 to the power of what? 3. Because 2 to the power of 3 is what? 2 times 2 times 2, which will give us what? 8. You see it now? So if I have something like 16, if I want to express it in index form, it will be what? 4 power what? 2, which will give me what? 4 times 4, which will give me what? 16. Are you seeing it now? So if I have something like 49, it will be what? 7 power 2, which will give me what? 7 times 7, which will give me what? 49. So that is what? Indices. Or example, I have 1 all over 49. It will be what? 1 all over 7 squared, which in turn will be what? 7 raised to what? Minus 2. Inverse of what? 7. Are you seeing it now? So this one will be what? The same thing as 1 all over 7 squared. But when we begin to talk about the laws of indices, this law will get us to negative what? Indices. We shall discuss the law. Now you have known what indices mean. Let us go to what we call what, because all these things I'm writing now will help us to know more on what indices, because I'm going to elaborate. Just stay tuned. Oh, I'm going to elaborate many things on what these indices. So a subtopic, reciprocal. Now you have been hearing reciprocals, right? What is this reciprocal? I'm asking you. Okay, you don't know. Okay, reciprocal simply means, okay, we used when we are small that time, we used to say respect is a reciprocal, respect is a reciprocal. And you sef, you don't even know what reciprocal means. All you be saying is respect is a reciprocal, respect is a reciprocal, but you don't know it. Should I tell you? Okay, let me tell you. I know you don't know it. So reciprocal simply means when the product of two numbers gives us what? One. The two numbers are reciprocals of what? Themselves. Let me write it. Okay, let me just write it like this. When the product of two numbers equals 1, the two numbers are reciprocal of themselves. So anytime product of two numbers gives you 1, you know that those numbers are reciprocals of what? Themselves. If they don't give you 1, don't go and say that they are reciprocal. My hand no dey am. So I hope you're enjoying this teaching. Let's go. This video will be a little bit longer because I'm going to elaborate many things on what this indices. So, example. So let me continue. Some children are just making noise, disturbing what I'm teaching. They don't have frequency. So I went and controlled them. So let's continue. Example. Where did I even stop? When the product of two numbers equals 1, the two numbers are reciprocals of what? Themselves. Example. If I have 5, what is the reciprocal of 5? Now, remember that this 5 is what? 5 over what? 1. Every number is standing on top of what? 1. Because 1 is what? An identity. So 5 divided by 1 is what? 5. Any number divided by 1, this one is the what? Dividend. Why this one is the what? Divisor. So any number that 1 is dividing, it will be what? That number. So what is the reciprocal of, where is my distance? So what is the reciprocal of this 5? The reciprocal of 5 will be what? Let's check whether I will get a number. When I multiply it, it will give me 1. So will be what? 1 over 5. Let's check. Remember, this thing is 1. This one will cancel this one. Our answer is what? 1. So they are reciprocal. Are you seeing it now? Now, for example, I tell you reciprocal of what? 6. It will be what? Just know that this 6 is what? 6 over 1. The best trick you are going to use, just flip this one up, flip this one down. Are you seeing it now? When I flip it up, I flip it down. That is the what? Reciprocal. So reciprocal of 6 and 1 will be what? 6 over 1 times 1 over 6, which will give us 1. You see it now? So when they ask you reciprocal of any number, you just write what? The down one versus what? The up one. For example, reciprocal of 5 over 6 will be what? Times 6 over 5. Carry this 6 and move up. Carry this 5 and go down. You get what? The reciprocal, which is what? Which will give us what? 1. Two of them are reciprocal. Now, see how I did this thing. 5 over 6. You just put 1 here. It will be what? 1 times. Remember, when division is changing to multiplication, this one will go up, this one will come down. It will be 6 over 5, which will give us what? 5 over 6 times 6 over. So, still on what? Indices. Now, dividing by a number, still on what? That same reciprocal. Let me just write it. Dividing by a number gives same value as multiplying by its reciprocal. As multiplying by what? Its what? Reciprocal. So, for example, if I have k divided by what? M. So remember they say dividing by a number gives same value as multiplying by what? Its reciprocal. So let's check whether multiplying the reciprocal of this thing will give us same value with k divided by m. So it will be k times reciprocal of m is what? 1 all over m. Which will what? Give us what? K all over m. And this k all over m is still the same thing with what? K divided by m. You see it now. So dividing by a number gives us same value by as what? Multiplying by what? Its reciprocal. Now we go to another distance subheading multiplicative inverse. Multiplicative inverse. Have you heard about multiplicative inverse? What is multiplicative inverse? Multiplicative inverse and reciprocal are what? The same thing. Reciprocals of a number are also known as what? They are multiplicative inverse because it gives us what? Multiplicative identity, which is what? 1. Let me write it. Reciprocals of a number are also known as their multiplicative inverse because it gives us multiplicative identity, which is what? Which is what? 1. So reciprocals of a number are also known as what? They are multiplicative inverse because it gives us what? Multiplicative identity, which is what? 1. Their product gives us multiplicative identity, which is what? 1. So if I say what is the multiplicative inverse of 5, what will you tell me? You just tell me 1 over what? 5, because 5 over 1 times 1 over 5 is equals to, it will give us what? Multiplicative identity, which is what? 1. So reciprocals and multiplicative inverse are what? The same thing, because their product gives us what? 1. So another thing I want you to know is, okay, let me just write this thing like this so that you understand it. Reciprocal of a number are also known as their multiplicative inverse because their product gives us, because their product gives us multiplicative identity. Their product gives us multiplicative identity, which is what? 1. So you can just write it like that. Just know that multiplicative inverse and reciprocals are what? Stay the same thing. Because it must give us what? 1 as an identity. Now, another subtopic, identity. What is an identity? An identity is any number that leaves another number unchanged after what? Operation, parenthesis, addition, and what? Multiplication. So let me write it. An identity is that number that leaves another number unchanged after operation. So an identity is that number that leaves another number unchanged after what? Operation. Now, parenthesis what? Addition and what? Multiplication. Multiplication. And you know that one is the only identity you know for what? Multiplication. Because one times any number, we give it what? That number. So that's it. Then another this thing, another subtopic is what? Additive inverse. Additive inverse. Two is the additive inverse of -2 because it gives us additive identity 0. So 2 is the additive inverse of what? -2 because it gives us what? Additive identity what? 0. So any number that gives you any number that gives you 0, like for example 10 is the additive inverse of what? -10 because it gives us what? 0. 11 is the additive inverse of what? -11 because it gives us what? 0. So the additive inverse of a number, comparing it with another number like 10 is the additive inverse of what? -10 because it gives us identity which is what? 0. So 0 is an additive identity. Remember what an identity means. That number, when get in touch with another number, it does not do what? Change the number. So 0 plus any number will not even do what? Change it. So that's it. So hello, if you are still on what? Indices. We are going to do what? Write the laws of what? Indices. Laws of indices. You know, in our secondary school, they gave us what? 7 laws of indices, but I will try my best to give you like 13 or 14, depending on. So let me ask you this question. On that additive inverse, what is an additive inverse? Remember, additive inverse simply means when the sum of two numbers gives us additive what? Identity, which is what? 0. For example, if I tell you 2, that 2 is the additive inverse of what? Minus what? 2. Are you seeing it now? Because it gives us what? Additive identity, which is what? 0. So 2 plus parenthesis -2 will give us what? 2 minus 2, which is what? 0. So additive inverse of any number must give us additive identity, which is what? 0. So that's it. So the laws of indices. First law, we have number 1, product rule. Product rule is telling us that if you have a raised to the power of b times a raised to the power of what? C, that is equals to what? A b plus what? C. You add the what? Powers. For example, you have 2 raised to the power of 3 times 2 raised to the power of what? 4. It will be what? Because the base are the same, it will be what? 2 raised to the power of 3 plus 4, which is 2 raised to the power of what? 7. This is your what? Answer. Unless you want to extend it. So the number 2 law, we have what? Quotient rule. Quotient rule is telling us that if you have a raised to the power of b all over a raised to the power of c, then this thing is equals to a b, the c will go up. When it crosses over this division sign, it will turn to what? Minus. So it will be ab minus c. The criteria for this is what? Where b is greater than what? C. If b is not greater than c, check it in another law. It will suit. So, for example, if you have 2 raised to the power of 3 all over 2 raised to the power of what? 2. This thing will bring out what? 1. 3 minus 2, which is give you 2 raised to the power 1, which is equals to what? 2. So that's it. So the third law, we have power rule. Power rule is telling us if you have a raised to the power of what? B times what? N. Now this thing is what? A to the power of b times n, which is what? A raised to the power of what? Bn. So that's the rule. Now the fourth rule, there's no, I don't want this video to be that long. That's why I'm not writing example. But after this video, I'm going to solve many questions on it. So number 4, we have zero index. Zero index is telling us that anything raised to the power of 0 is what? 1. See how we got it? For example, a raised to the power of n all over a raised to the power of what? N. It is what? A raised to the power n minus what? N. N minus n is what? 0. So remember, this one can cancel out. We are left with what? 1. So a raised to the power 0 is what? 1. So that's how we got it. So number 5, power rule 2. Power rule 2 is telling us that if you have a raised to the power of what? B. Is it power rule 2? No, it's not power rule 2. Okay, let me write this one first. I think it's not power rule 2. Let me write this one first. Interchange of exponents. Interchange of exponents. Interchange of exponents. It's telling us that if you have a raised to the power of b raised to the power of what? N. That this thing can be what? A raised to the power of n raised to the power of what? B. So this one is interchange of exponents. So number 6. If you have a raised to the power of what? A is equals to b raised to the power of b. That a is equals to what? B. So I don't know the name of this rule, but you can say by comparison. But this rule is very, very important. So number 7, negative indices. Negative indices. If you have a raised to the power minus 1 is equals to what? 1 over a raised to the power of what? 1, which is 1 all over a. So this one is negative indices. So number 8, power rule 2. It's telling us if you have a times b raised to the power of what? N. That is equals to a raised to the power n times b raised to the power of what? N. So this is power rule 2. Then number 9, if you have equal base law, is this rule. Equal base what? Law. It's telling us if you have a raised to the power of b is equals to a raised to the power of c. The bases are the same, you equate the what? Power. B is equals to what? C. So number 10, equal exponent law. It's telling us that if the exponents are the same, you equate the what? Base. For example, a raised to the power of b is equals to c raised to the power of what? B. That a is equals to c because the exponents are what? The same. So number 11, fractional law 1. Fractional law 1 is telling us that if you have a raised to the power of 1 over 2, that is equals to what? The radical of what? A raised to the power of what? 1. That's the square root of a raised to the power of 1. So that's fractional law 1. So number 12, fractional law 2. It's telling us that if you have something like a raised to the power of what? Are you seeing it? A raised to the power of 55 all over 20. That is equals to what? The 20th root of what? A raised to the power of what? 55. This is fractional what? Law 2. So Number 13. Number 13, reciprocal rule. So I just thought of this reciprocal rule in my mind when I was still learning indices, making more research on what indices. So I produced this reciprocal what rule. So what is the rule telling us? Because I know that reciprocal of a number is when the product of two numbers gives us one. So if you have from I escalated this reciprocal rule from negative indices. You know, in negative indices, if you have inverse of a, that is equal to what? 1 all over a. You know that one raised to the power of what? 1. So if you have 1 all over a raised to the power of -1, this will lead us to what? A law called what? Reciprocal rule. So it will be what? 1 all over 1 all over a. So which will give us what? 1 times, then that one will flip up a over 1, which will give us what? A over what? 1. So this is what we have. 1 all over a times a over 1. It gives us what? 1. So it is what? Reciprocal rule. Remember I told you that I um, emagnated it from what? Negative what? Indices. So number 14. Number 14. Quotient rule 2. Quotient rule 2. Is it quotient rule 2? Is somehow quotient rule and power rule combined together. Just see the rule. If you have a raised to the power of b all over a raised to the power of c raised to the power of what? N. This thing is what? A raised to the power of bn all over a raised to the power of cn. So the quotient rule 2 combined with what? Power rule. So let me think whether I can get another rule. Indices. Like all the rules I know are finished. All of them are finished. So thank you for watching and may God bless you. Please don't forget to subscribe on our YouTube channel. Follow us on our Facebook page. I will be solving many questions on what this indices. Bye bye.